In this video, we'll be looking at the mole concept. The mole concept is like the glue in chemistry calculations. The mole ties together the number of particles, the mass of a substance, and also the volume of gas. First, let's look at what is a mole. Mole can be seen like pair or dozen. One pair of shoes has 2 shoes. And 1 dozen of eggs has 12 eggs. 1 mole of gold has 6.02 times 10 to the power of 23 elementary units. And what are the elementary units here? Since gold is made of atoms, therefore 1 mole of gold has 6.02 times 10 to the power of 23 atoms. You can see here the usage is very similar to pair and dozen. The mole represents a specific number of substances. So 1 mole of carbon dioxide, since carbon dioxide is a molecule, 1 mole of it will have 6.02 times 10 to the power of 23 molecules. We can see here the magic number is 6.02 times 10 to the power of 23. This is also known as Avogadro's constant. 1 mole of potassium bromide. Potassium bromide is an ionic compound. Therefore, it is made of formula units. It is made out of ions. But we refer to each KBr as a formula unit. So 1 mole of it will have 6.02 times 10 to the power of 23 formula units. Now that we understand what a mole is, first let's look at the relationship between the number of moles and the number of particles. The number of moles and the number of particles are related by the formula the number of moles N is equals to the number of particles divided by Avogadro's constant. This is how the number of moles is related to the number of particles. Let's just make a note. Avogadro's constant is equals to 6.02 times 10 to the power of 23. The unit for this is per mole. There are 6.02 times 10 to the power of 23 particles per mole of substance. Let's try out some calculations. Calculate the number of atoms of the following substances. In A, we have 0.3 moles of helium. We are given the number of moles, this is N, and we are required to find the number of atoms. When we want to relate number of moles to number of atoms, it is moles is equals to the number of atoms. The particles here are atoms, so number of atoms over Avogadro's constant. Avogadro's constant is written as N subscript A. And so the number of atoms would simply equals to number of moles multiplied by Avogadro's constant, and that is the number of moles is 0.3, Avogadro's constant is 6.02 times 10 to the power of 23. This is equals to 1.806 times 10 to the power of 23. This is the number of helium atoms in 0.3 moles of helium. Let's try another one. Calculate the number of molecules this time in the following substances. Let's look at B. Here we have 8.2 moles of water. 8.2 moles is the number of moles. We are required to calculate the number of molecules. That is the number of particles. And so in this case, N, the number of moles, is related to the number of molecules by moles is number of molecules divided by Avogadro's constant. Therefore, number of molecules is simply equals to number of moles times Avogadro's constant. And so this is 8.2 multiplied by 6.02 times 10 to the power of 23. And the number is 4.936 times 10 to the power of 24 molecules. You can do the same with the number of formula units as well. Calculate the number of formula units in the following substances. Let's look at 1.4 moles of zinc oxide. How many formula units of zinc oxide are there in 1.4 moles? Again, the relationship is number of moles is this time number of formula units divided by Avogadro's constant. Once again, number of formula units is simply, we just have to rearrange this, number of moles times Avogadro's constant. And so this will be number of moles, we have 1.4 times 6.02 times 10 to the power of 23. The answer is 8.428 times 10 to the power of 23. This is the number of formula units of zinc oxide in 1.4 moles of zinc oxide. Next, let's look at the number of moles and mass of substances. Number of moles is related to the mass using the formula number of moles equals to mass divided by molar mass. But what is the molar mass? The molar mass is the mass of 1 mole of substance. Hence, it's called the molar mass. The value of the molar mass, is equals to the value of the relative mass of the substance. Let's try some calculations. Calculate the mass of the following substances. Let's start with 0.6 moles of copper. Here we are looking at number of moles and we are required to calculate the mass. And the relationship between the two is number of moles is equals to mass over molar mass. The molar mass of copper is the relative mass of copper, and the relative atomic mass of copper is 64. This can be found in the periodic table and is usually given. Let's rearrange this to make the mass the subject of the equation. So mass will equals to mole times molar mass, which means this is 0.6 multiplied by 64, and the answer is 38.4 grams. When using the formula, the mass will be in grams. Let's try a slightly more complicated one. What is the mass of 3.1 moles of ethanol? Once again, we are given the number of moles and we are required to find the mass. The relationship between the two is moles is equals to mass over molar mass. And therefore, the mass will equals to the number of moles multiplied by the molar mass. The molar mass is the relative mass. And for this molecule, we look at the relative molecular mass. How do we count the relative molecular mass? We have to add up the relative atomic masses. So relative atomic mass of carbon is 12. Hydrogen is 1. This will be given usually, and oxygen is 16. If not, it can be obtained from the periodic table. This is the relative atomic mass. Let's put this into the formula. The moles of ethanol is 3.1. The molar mass of ethanol will be the relative molecular mass, which means we have to sum up all the relative atomic masses of all the atoms. We see there are 2 carbon atoms in ethanol, which means we have to multiply 2 times 12 because the relative atomic mass of carbon is 12, and 6 hydrogen atoms, which means we have to add 6 times 1 since the relative mass of hydrogen is 1 and we have 1 oxygen, so 1 times 16. And the answer here is 142.6 grams. The same thing applies to ionic compounds as well. What is the mass of 0.72 moles of lithium oxide? Relative mass here would be relative formula mass, because this is an ionic compound, therefore it would have formula units instead of molecules or atoms. And the same thing applies. The relative atomic mass of lithium is 7. Once again, oxygen is 16. Let's apply the formula. We are given number of moles. We need to find the mass. The relationship is moles is equals to mass over molar mass. That means mass is moles times the molar mass. and the number of moles is 0.72. The molar mass is the relative mass. In this case, the relative formula mass. We have 2 lithium ions in lithium oxide. Therefore, we must multiply 2 times 7, and we have 1 oxygen, which means 1 times 16. Remember that the mass of an ion is equivalent to the mass of an atom because the mass of electrons are negligible. The answer here is 21.6 grams. Next, let's look at the number of moles and the volume of gas. The number of moles is related to the volume of gas by the formula moles is equals to volume over molar volume. You can see the similarity with the relationship with mass. And what is the molar volume? The molar volume is defined as the volume of 1 mole of gas. That's why it's called molar volume, just like molar mass. However, unlike molar mass, which is dependent on the type of substance, the molar volume is constant and it only depends on 2 things. The volume occupied by 1 mole of gas is similar at the same temperature and the same pressure. If the temperature and the pressure is the same, the volume occupied by 1 mole of gas is the same. Let's say I have a balloon filled with 1 mole of oxygen gas. 1 mole of oxygen gas. Let's say I have another balloon and this balloon is filled up with 1 mole of methane gas. You can see we have 2 different gases here. One is oxygen, this is made out of 2 atoms, and then we have methane made out of 4 atoms. However, these 2 gases will occupy the exact same volume, which is the molar volume. How is this possible? This is because we assume that for gaseous particles, the gas particles are very far apart. They are so far apart that we assume that there is negligible force of attraction between the particles. There's no force of attraction between any 2 gas particles. This means it doesn't matter if it's an oxygen molecule or whether it's a methane molecule. It doesn't matter because neither have any significant force of attraction between the gas particles. And so the volume occupied by both would be the same. However, this is affected by the pressure as well as the temperature. A higher temperature would cause the gas to expand and therefore change its volume. A higher pressure will cause the gas to contract and therefore change the volume as well. And so, if we fix the temperature and the pressure, all gases, regardless of the type of gas, will have the same volume. There are 2 specific conditions that we use, that is called the standard temperature and pressure, and the other condition is known as room conditions. At standard temperature and pressure, the temperature is set to be 0 degrees Celsius. The temperature and room conditions cannot be referred to as just any room temperature. This is because the room temperature varies from place to place. Instead, this is also a fixed value of 25 degrees Celsius. Under the STP, the pressure is 1 atmosphere. That is atmospheric pressure. This is the same here as well for room conditions. The pressure is the same, only the temperature is different. And the molar volume at standard temperature and pressure is 22.4 decimeter cube, not centimeter cube. Whereas the molar volume at room conditions is 24 decimeter cube. This is the molar volume at STP and room conditions. Let's try some calculations. Calculate the volume of the following gases at room conditions. 0.5 moles of helium, Now we are trying to find the volume. We are given the number of moles. The relationship between the two is moles is equals to volume over molar volume. And therefore, volume is moles multiplied by molar volume. Number of moles of gas here is 0.5. And the molar volume, this is for room condition. At room condition, the molar volume is 24 decimeter cubes. And therefore, the volume is 12 decimeter cube. Let's try another one. Calculate the volume of the following gases at STP, standard temperature and pressure. Let's look at 7.1 moles of sulfur dioxide. Here again we are given the number of moles and we are required to find the volume. The relationship is moles is volume over molar volume. Therefore, volume is moles times molar volume. And the molar volume at STP is 22.4. 7.1 moles multiplied by 22.4 this time because it is under standard temperature and pressure. And the answer is 159.04 decimeter cube. Notice here we use the exact same formula and the exact same value for molar volume regardless of the type of gas, whether it was sulfur dioxide or helium. Calculate the number of moles of the following gases at room conditions. Now we are given the volume. This is 280 centimeter cube, the volume of the gas, and we are required to find the number of moles. Once again, they are related by the same formula. Moles is volume over molar volume. Now when we substitute volume into the formula, we must remember that volume must be in decimeter cube. It cannot be in centimeter cube. So what is the conversion from centimeter cube to decimeter cube? 1 decimeter cube is equals to 1000 centimeter cube. And therefore, if we are converting from centimeter to decimeter, the operation would be divide by 1000. If we are converting from decimeter to centimeter, the operation would be multiply by 1000. In this case, we want to convert centimeter to decimeter. Therefore, we divide by 1000. And so the volume would be 280 divided by 1000 decimeters over the molar volume. The molar volume we have to check. In this question, it is room conditions. Therefore, the molar volume is 24. And the number of moles will be 0.012 mole. We just have to remember to convert the volume to decimeter cube when using this formula. Let's put all three relationships together. The number of moles of a substance is equals to the number of particles divided by Avogadro's constant. It is also equals to the mass of a substance divided by the molar mass of the substance, which is also equals to the volume of a substance divided by the molar volume of a substance. Now, if we are given any of these variables, we can find the other using this relationship. For example, if we are given the mass and we are required to find the volume of a substance, we can use the relationship the mass over the molar mass of the substance is the volume over the molar volume of the substance. Let's try some calculations. Calculate the volume of the following gases at room conditions. We have 12 grams of helium. Here we are given the mass of the gas and we need to calculate the volume of the gas. How are these two tied together? By the mole, because the mole is equals to the mass over molar mass of gas, which is also equals to the volume over the molar volume of gas. So we can use this relationship. Now all we have to do is substitute our values in. Mass of helium is 12, molar mass of helium is 2. This would be given to you, it's the relative mass. And the volume is what we want to find over the molar volume. Since this is room conditions, molar volume is 24. And so the volume will simply be 12 over 2 times 24. which is 144 dm cube. Now you can see how everything ties in together. This is the mole, the glue in chemistry calculations. If you want to do some more advanced chemistry calculations, you can check my video on the 5 steps in chemistry calculations. I'll leave the link for you in the description below. If you've learned something today, please help me hit the like button. Really appreciate it. Thank you very much for doing that. And if you like videos like this, do subscribe because I'll be producing at least one video a week. See you guys in the next video.